All right, so chapter 2 is referencing linear functions. And the textbook has a really good graphic that they use to kind of display all of the information. But essentially, we can look at a linear function in 4 different ways: a table, a graph, an equation, and a situation. So a lot of what we're going to do this chapter is essentially being able to go from one to the other. Okay, so essentially, if you're given a graph, can you make a table? If you're given a table, can you make a situation? Situation to an equation, right? Any which one, okay? Today, we're going to focus on just one of them. So our linear function equations are always going to follow the same format, okay, that you have probably seen before, which is y equals mx plus b. Okay, where x and y are always going to be x and y. Okay, and then m and b are what's going to be your variables. Those are the ones that are going to change based off the situation. And then our b value is going to be either our starting value or our y-intercept. Again, they mean the same thing. Okay, whenever x is equal to 0, okay, y is going to be your y-intercept will be your starting value, okay, that we plug in for b. So today we're going to talk about going back and forth between a table and a graph. So let's say we got the equation here, y equals 3x plus 1, okay, and we want to convert it into a table. Okay, a couple different ways you can do it. Some are easier than others. Okay, the one way would be, okay, let's take 0. We're going to plug it in for x. Okay, and then we're going to solve. So then we get 3 times 0 is 0 plus 1 gives me a y value of 1. You could do the next thing for 1. Y equals 3 times 1 plus 1. Y equals 3 plus 1. Y equals 4. And we plug in 4. You go to 2 and plug in 2. Okay. It gets a little monotonous after a while. Okay, but we could keep doing it. The easier way, okay, would be to recognize, okay, what is my starting value? Okay, and what is my growth? So here's my starting value, 1. That's going to be what I plug in when x is 0. This is my growth. It means what I'm growing by each time. So I know that as I go from one number to the next, I'm going to be adding 3. So now I can just go 1, 4, 7, 10, 13, 16, so on and so forth, as opposed to plugging it into an equation each time. Okay, if I can just recognize what my starting value is when x is 0 and understand what my growth is each time, in this case, 3. All right, so again, we're taking our equation, trying to put it into a table. Okay, what is my starting value going to be when x is equal to 0? Very good, -5. Okay, so I start at -5. This is telling me that I'm increasing by 2 each time. So if I increase from -5, gets me to -3, then gets me to -1, then +1, then 3, then 5, so on and so forth. Much easier than plugging it into each one. Hey, have you try one here on your own, making it a little tricky as well. All right, try that one. All right, so we plug in, again, we could plug in 0 or easier way. Here's our starting value 1. Okay, -3, okay, is my growth. Okay, so I'm actually subtracting 3. So 1 minus 3 would be -2, -5, -8, -11, -14. Okay, going that way. So if there's a negative out in front, okay, we'd be subtracting from one term to the next. Positive, we are adding. This should have definitely said equation, not graph. Just realizing that. My apologies. Okay, so we went from an equation to a table. Now let's go from a table to an equation. All right, so if you think about what were the key things we were looking for when we were given the table to write our equation, kind of doing the opposite. Okay, we're looking for what is our value when x is equal to 0. Okay, and we're looking for what is happening between each term. Okay, so when x is 0, y is 7. So to write our equation, we should know that it's going to be a +7 at the end. And as we go from each term, from one term to the next, we're adding 3. So our m value is 3, giving us the equation y equals 3x plus 7. All right, second example here. Once again, looking for what is y when x is equal to 0. In this case, it's -5. And then once again, understanding what's happening going from one term to the next. 5, -10, -15, -20. We are subtracting 5. So we get y equals -5x minus 5 for our equation there.